All right, guys, I wanted to give you a little bit of review here for the finance stuff, just kind of refreshing your mind on formulas and stuff. So I've already written out the formulas we're going to use just to save you time in the video here, so I don't have to write it all in there. But just a couple of reminders on the difference between annuities and just your regular, compound interest formulas and stuff like that. So I'm going to just kind of go through each one of these, talk about them a little bit. I may skip around, we'll see. So first one, $900 is borrowed for 4 years, interest rate of 8.7%. How much do you need to pay back? So this is your future value simple interest. It says how much do you need to pay back? So it's the future value of what you're going to pay back. You know you have to pay back the $900 plus additional interest. So your amount has to be bigger than $900 here. So it's our simple interest formula. Remember, the P is the amount that you're going to borrow. So that's your P. Your T is your years. And then your rate, remember, you have to move the decimal place over 2, so it's 0.087. Okay, so just a reminder on little tips there for what you got to do. And then literally you're just going to plug those values in here. A is the future amount, hence the A. So you're going to plug that in, just literally plug into the formula as to what every variable stands for, and then go straight to the calculator. Remember, when you go to the calculator, you're going to type this in exactly the way you see it. So I'm going to go 900, 1 left parenthesis, 1 plus, and I'm literally just plugging this in just the way I had it written, close the parentheses, and there's my answer. Okay, so don't mess around with pressing equals and all that in between. So my final answer is the 12, 13, 20. Okay, and again, I'm going to allow you to look back at the answer key on these. Number 2, so this is a payment one. You're borrowing $170,000 for a house. So $170,000 is your mortgage. That's how much you're going to take out here for a loan. You're going to go for 20 years, interest rate. So this is your P value. This is your time is 20. Interest rate is going to be, again, move that decimal place, so 0.0425. And it's compounded monthly. So remember that that's your N value. It's the N represents the number of times it's compounded per year. So since it's compounded monthly, your N value is 12 because there's 12 months in a year. And then it says, what is your monthly payment? And remember that whole rounding up thing. So it says round your answer up. So no matter what, you're going to round it up to the nearest dollar. Okay? So you plug all that in and you go to the calculator. All right, now I'm just going to go to the calculator right now so you can look back at the answer key. But I'm going to remind you how to plug this in. So it's a fraction. So I'm going to go green button, y equals, and get that fraction button. Everything in the top, so my P is 170,000. I have another fraction, so I'm going to go times another fraction. And I'm going to plug in that rate, 0.0425, arrow down, and then there's my N value. So that's the top of the fraction in the formula. Now I go to the bottom. So I have 1 minus 1 plus new fraction. 0.0425, arrow out, close the parenthesis, and then I'm going to raise it to the power of, so that's the little caret over here underneath the clear, and then I'm going to put 20 times 12, and there's my, oh, what did I do? I did something wrong. Oh, it's supposed to be a negative. Let me go back up and grab it. This is a negative in front. And so that's my answer there. And it says round up to the nearest dollar. Yes, it's a 0.6, so it's going to round up anyway. But if that's a 0.1, I still round it up to 1053. Remember what that means for a round up. So your monthly payment is going to be $1,053. Okay. Now I'm going to take this problem a little bit further here. Remember, over that 20 years, you're going to pay back $170,000 plus interest. So how much do you actually put in over the 20 years? Well, you're going to take that monthly payment every single month, so I'm going to multiply it by 12 for 20 years. So this is how much money I'm going to put in over the 20 years. And when I do that, that is going to give me $252,720. So over the 20 years, that's how much money I actually put in. So how much of that is interest? Well, we have to subtract off of that the $170,000 that we originally owed, right? So if I subtract $170,000, because you know I have to pay back that, I get $82,720. So that's how much I pay in interest over the 20 years. So if it ever asks how much in interest, remember you're going to subtract that. So this is how much I put in total, and this is how much I pay in interest. Okay, so that problem wasn't asking that. I just kind of took it to the next level there. Okay, moving on to number 3. So number 3 is saying how much needs to be invested now. Those are key words. I'm going to invest it one time and one time only, right now. That means it is not an annuity. Remember the annuity, the big long formula, is when you invest something monthly, multiple times. I keep investing. This is one time. I'm going to invest it now, and I want to have $25,000 at the end. So my $25,000 is my future value, and because I'm only investing it once, it's my compound interest formula. Okay, not the annuity formula. So your A there is your future value. Convert that to a decimal. So 25,000 is my future value here. I'm finding out what my P is. 1 plus my interest rate. N. So what is my N here? Well, let's see what it's compounded. Interest is compounded monthly. Again, N is the number of times per year. So that's 12. And my exponent is 7 times 12. Okay, now, when I do this, I go to the calculator. What am I going to do? To solve for P, I'm going to have to divide by all of this. So what I would do in the calculator is I'm going to divide this whole thing by that. So I would go, and this is how I would do it. Again, I'm going to do the fraction button, and I'm going to take the 25,000, and I'm going to divide by all of that. So I'm going to divide by, oops, I got to put parentheses. 1 plus new fraction, 0.035 over 12 to the power of 7 times 12. So you can just put that in there, and there's your amount. That's how much money I have to put in right now, one time. And what does it say to round it to? It doesn't specify, so you're just rounding it to the nearest penny. Okay, so again, you can refer to the answer key on that, but I wanted to remind you how to put that in the calculator. Okay. Number 4. So number 4 is, again, the same type of problem. 4,000 is invested as a lump sum. That's a key word. That means one time. I'm putting this 4,000 in one time. It's not an annuity. It is not an annuity. After the end of the 5th year is what I want to figure out. Again, compounded monthly, so our N is 12 again. So I'm finding what is my future value, what is my future amount in 5 years. I start with 4,000. I'm plugging this in, and again, I'm going to go to the calculator straight, and I'm going to type this all in all at once. Okay, so make sure you can get that correct answer there. Refer to the answer key. Number 5, remember this is that, it says annual yield. There's only one time you're going to use this formula. It's when it literally says annual yield. So you just kind of plug everything in there. I'm going to kind of skip that one. It's the only time you're going to use that formula. Remember, we don't use that formula that much. Okay, number 6. So number 6 says they're going to save $55 per month. That's the key here, per month, meaning every single month. If you're in my class, I would always pound my hand. Every single month we're putting in $55. So that means it's annuity, it's the big formula. Okay, so the $55 is your P. That's your amount that you're putting in every month. And it is compounded monthly, so because the per month and the monthly line up, we don't have to do anything fancy. I know we've done some other problems. You don't have to worry about that. They're going to line up here. So 18 years later, we want to find out what our future value is. So we're going to find our A, and notice we're rounding to the nearest dollar. Rounding to the nearest dollar. So I'm just going to go to the calculator again and show you how to do this. So refer to your answer key, but I'm going to do my fraction. So in the top, I have my 55. 2 left parentheses. You write it in exactly the way you see it. Another fraction. 0.073. And I got my 12 in the bottom. Raised to the power of 12 times 18. Arrow out of that, and then put -1, and then you've got the closure. So again, you should always have 2 decimal places, or sorry, not decimal places, 2 parentheses there in the left. And then in the bottom, new fraction. Your calculator should look exactly like what your formula looks like. Should look exactly like that. It says round to the nearest dollar. I'm not rounding up, I'm just rounding to the nearest dollar. So I end with the 7 there, the 67. Okay, so you can check that answer. So that's the annuity formula again. That's that type. Number 7, last one. So how much should you deposit each quarter? Each quarter, I'm going to deposit money in every single quarter. That tells you it's annuity. And it's compounded quarterly, so that's nice again. They line up, the quarterly and the quarter, and we're putting in, so we don't have to make any adjustments there. We want to have $10,000 in 7 years. That means in 7 years, my future amount is $10,000. So this time, my $10,000 is my A. I'm finding my payment. 2 parentheses. 1 plus 0.0625, because that's my rate. And quarterly, how many times per year is that? Per year. Remember, your N is per year. That's 4 times. And then we have the 4 times the 7 over the 0.0625 over 4. Now, there's different ways you can do this one in the calculator. So what I always like to do is I like to just multiply these two together and then divide by all of this. Okay, so if I'm going to the calculator on this one, or you can just figure out all of this, and then just divide 10,000. I think that's how we did it before. That's what we'll do. So I'm going to calculate all of this first. I've made a mess now of my fraction. So we're going to calculate all of this in the calculator, and then we're going to go 10,000 divided by that and go grab it. So I'll show you how I'm going to do that. I'm going to do all of that. So I'm going to do my fraction. And so I have 2 sets of parentheses. And I go 1 plus new fraction. Arrow out of it. Arrow out of that set of parentheses. Raised to the power of 4 times 7. Arrow out. -1. And then I have a new fraction in the bottom. 0.0625 over 4. So that's what was all times that P. So now I'm going to take 10,000 divided by that. So remember, go up and grab it, press enter, and then there's your answer. So that's going to be your payment. When I say payment, I mean every single quarter, that's what we're going to put in. And so that's how you get the answer there of 287.44. What does it say? Round to the nearest cent. So every quarter you have to put in that amount in order to have your $10,000 at the end of the 7 years. All right. Good luck.